We're joined by Slater Stich, a partner at Bain Capital Ventures, who partners with the architects of tomorrow, crafting the very tools that data teams across the globe will come to rely on. Our discussion extends beyond the mere capabilities of Texas SQL, venturing into the heart of the modern data stack's lifecycle. With the initial fervor possibly subsiding, what lies ahead for this critical aspect of the tech infrastructure? Are we approaching a consolidation phase, or will this be a moment of metamorphosis, birthing innovations that we can scarcely imagine? Moreover, Slater offers his perspective on the gestation period of AI agents, those critical entities poised to redefine our interaction with technology. Is this full integration a matter of months, or are we looking at a more protracted timeline, punctuated by ethical considerations and technological breakthroughs? But this is more than just a technical discussion. We explore the philosophical underpinnings of venture capital's power law distribution, the ethical dimensions of rapid technological advancement, and whether we're in the midst of an AI bubble or in the precipice of a foundational shift in how we interact with technology. So if you're intrigued by the intersection of technology and the future of data infra, join us for a conversation that promises not only to inspire, but to enlighten. This is your portal to the minds crafting the future. We look at the what of AI, but the why and how it's transforming our world. Let's dive in. All right, Slater, thank you so much for joining us on the Collective Intelligence podcast. Let's just start off by having you tell us about your prior work experiences, why you chose those positions, and what you're most proud of, and how that led to your current work.
Yeah, I mean, so very briefly, out of undergrad, I thought I was going to be a math academic. That's what brought me out to the West Coast originally. I spent a few months doing that and then decided that working in industry was more interesting. So I dropped out of a math PhD, went to go work at an early stage startup called Elastic Box as a backend developer there. This was kind of in the mid 2010s. And so that's when data science, data engineering was sort of emerging as a discipline. I got really interested in that, went to Square afterwards, where I worked for a few years, and then went through a few different data IC, data leadership roles until I gradually found myself more on the investing side. And so I led the data team at a growth equity fund called Valor Equity. And then off of that, I started my own small fund called Activation. The whole idea for which was just, I want to invest in tools for data teams that I wish I had had in the past, things that would have made my life easier or the teams that I worked with would have benefited from. So I focused on that area. And then about a year ago, I joined Bain as an investor on the early stage infrastructure software team. And I still spend about half of my time focused on data infra, but invest more broadly in infra as well.
And why the decision to join a sort of larger platform as opposed to kind of going off on your own, doing your own thing and on your own platform?
Yeah, there's a few reasons. One, I really liked the team-based approach at Bain. I feel like I had this domain that I hopefully knew something about and sort of spent a few years in. And that's useful on its own, but it works even better as part of a team of people who have their own sort of different specialties, areas of specialization. So for example, Enrique on the team, who was the CEO of Symantec before, knows far more about security than I will. And just having different people with different backgrounds, I think offers a really great product to, infra founders. And I can just be able to pull people in to companies, that are in one domain, but having different perspectives is really useful. And the other thing is, I also just felt like I wanted to expand a bit the set of areas that I invested in, and it made sense to be part of a platform that could do that.
And how did the decision to move from sort of engineering to investing side is something that a lot of people in Silicon Valley grapple with. On the one side, you get to build, cool products and have something you can point to as something you've done but on the other side, as an investor, you get to meet with a lot of great people, exchange a lot of great ideas, think about the space more broadly. What was the framework that you used or developed for yourself to make that decision?
Yeah, I mean, part of it comes from the time at Valor. So I did two things there. I led what we called a data platform team, which was underwriting new investments. But then also we had this team that would work with portfolio companies to help them build up their data infrastructure, sort of recruit in leads for different data teams. And and so doing that, I spent a lot of time just trying to think about implementing data stacks across different portfolio companies. And so I just found myself spending a lot of time talking with early stage founders who were building tools that I wanted to use, right? So we spend time talking with like DBT or Fivetran or the folks at High Touch and other places. And I just got really, really interested in working with people who were building tools that I wanted to use. And so, that to me is kind of how I started spending more and more time doing that, where suddenly I found myself spending half my time just trying to understand what people were building so that I could use it. And so doing that, I just started thinking to myself, some of these companies, the founders are fantastic and I really believe in what they're doing and I'd like to invest in them. And that was sort of the transition for me is when I started thinking more about investing. And it was always very product driven. It was just that I think this person has identified a really valuable problem to solve. And I love the way that they're productizing that. I love the way that they're kind of taking what they know about this area and turning it into something that it's not just going to benefit like a handful of experts who've dedicated their lives to that one infra area. They've turned it into a product that every data team can benefit from.
Yeah, I think there is something to the fact that although when you're an engineer, you go deep, and I think people think that it means that you inherently just know what's going on broadly in the field, whereas I always felt that I'm focused on this one thing. People will ask me about 10 other things, 10 other platforms or tools. I couldn't give them a strong response because I was focused on building this one feature, one tool. And I think when you're on the investing side, you also are able to take the time and be intentional about learning about all the tools in the landscape. I think that it requires an intentional effort as opposed to something that just oftentimes it doesn't just happen. You have to be intentional about learning about different things that are happening in the ecosystem. But
I think I mostly agree with that. I think maybe one kind of like second order thing I'd add is that you're sort of trying to look at everything, but also any particular company opportunity, just the level of depth you're describing and like really understanding what's happening, sort of at the concrete level matters a lot. So
Right.
Things that look similar from the outside, like I don't know, take a problem like data transformation or like model inference or something like that. From like afar, there's like a lot of things that look really similar to each other, but like up close, they actually are really different. And, in some way, you can think of there's like some path dependence, right? It's like maybe they all look, they're clustered today because there was sort of a similar starting point or the companies aren't that old, but 10 years from now, these are going to be like very different perspectives on the space. And so, I think the level of depth you're describing is rewarded as well.
Yeah. That's such a great point, which is as an investor, you also hear a lot of fluff. For example, we are an ML platform. When you dig deeper, it's like more of a data processing platform. We are a NoSQL database with the fastest NoSQL database. You dig deeper, and there's all these other design decisions that were suboptimal. So definitely by going deep, you see insights that someone who just kind of reads a pitch deck won't have understood.
Maybe just one more.
Yes.
I'm probably going to stop interrupting you, but like maybe one other thing on that is that I like reading history of technology. And like one thing that's funny to me is when you look backwards at things that ended up being really valuable, they always had very, very concrete reasons why they were valuable. So it was never, I feel like there's this natural temptation to kind of like pitch what you're doing in kind of like very broad aspirational terms, where this is about being like a data-driven organization, or this is about democratizing ML or something like that. But day to day, what people want to do is like get data out of CSVs or like fine tune more efficiently, or like, hey, I just need this model inference solution to work. Similarly, if you looked, I always think it's funny to think about what it would look like if you looked backwards for other industries. So it's like in chemical engineering, for example, there was this moment when people figured out how to create aluminum much more cheaply, and nobody would ever have pitched that as like, we're democratizing chemical processes, or like, this is your innovation strategy for chemicals. It's like, no, we want cheap aluminum, right? And like, that's the thing that's valuable. And kind of like in a similar way today, it's like, I'd like model inference that just works, or like, I need to be able to fine tune on this particular, corpus or whatever it is. But those concrete problems, I think, are often like somehow undervalued. Like there's too much value in abstraction.
Yeah, I definitely see what you're saying. And you also, you definitely see parallels with not just our own industry, but industries outside of tech. So thank you for giving us a quick background. We start every event from our 200-person summits to 20-person small meetups with an icebreaker to get to know people on a personal level. So if you could teach a course on any of your side hobbies, what would it be, and how would you structure the curriculum?
Yeah. So I've thought about this a little bit, and one thing I think it'd be fun to do is kind of a like speed run of the historical development of calculus and analysis for people who already know the subject. So people who sort of, none of the facts would be surprising to them, but the history is interesting. And I think there's a couple of interesting things to pull out of that. One is there's this pattern where like the general theory is so valuable and solves so many specific problems that we forget about the specific solutions. To me, this is kind of like the math equivalent of Sutton's bitter lesson, where it's like you want to choose some architecture where you can really just scale up the data that you're giving to it, as opposed to sort of very clever feature engineering or something like that. So like the calculus example is there's this guy Wallace pre-Newton, or maybe just think about how you solve this problem. You want to integrate x to the q for some rational number q, and you want to integrate that between 0 and 1. So obviously calculus like trivializes this problem, but like how would you solve it if you didn't have access to any of that? And people had really, really ingenious ideas, and like whole papers were written on like solving special cases of this problem. Nobody remembers any of that today because like the general theory, like calculus, was just so powerful that we just didn't need to remember any of that stuff. And it's kind of an interesting lesson where like by weight, many of the papers are just made irrelevant because of this, very general solution. So I think that's one interesting parallel. And then the other one I was thinking about recently is just that like the practical sort of like street fighting way of like using this stuff like far antedated sort of the formal theory. So you have like Euler running around like solving the Basel problem or whatever, and sort of productively like using calculus and then Fourier analysis to great effect, even before any of the stuff had really been formalized. And there's all this like weird infinitesimal stuff and nobody really understands it, and you try to formalize it and it doesn't quite make sense. And there's these long sections at the beginning of all their books where they're like trying to like get to like what a limit is or something. And anyway, to me, again, like the lesson from this is just like, it does feel similar to me to like some parts of deep learning today, where like if you took like diffusion, for example, there's maybe like 10 competing perspectives on like what's really going on, and they all work. It's sort of like this is inspiration for like a thing that works, and so like the practical effects kind of can easily kind of predate the general theory. I think that's interesting too.
And I also think like there are some if you go to like to 2015, 2020, there was a lot of problems that were solved for that paradigm that may not be as necessary in today's world, where I feel like in 2015 to 2020 people were focused on fine-tuning vertical specific models, whereas now I think people are more focused on using sort of general purpose models and maybe using RAG to support those models. And so a lot of the tools that people, or frameworks that people work very hard to develop to support a more specific verticalized model are maybe no longer as helpful as they were, for that kind of that couple of years period, because people were just end up going to be using sort of general purpose models.
Yeah, I sort of, I guess I sometimes think about this as like, are you standing in front of the wave, or are you sort of being pushed forward by the wave, right? So like if the general technology, like if language models get like an order of magnitude better, is that good or bad for what you're trying to do? And I think some forms of verticalization, it's good, right? If it's sort of like you've specialized at the customer's use case really well, you're deeply embedded in their workflow. If the base model kind of gets better, that's great for you because you can just deliver a better service for your customers and they're not just going to, go do something else. I think it's bad for you when, the way in which the base model gets better, sort of reduces the need for that verticalization, if you will. Like it's not, the 5 things that you did in order to make like a lower tier model work, you don't need to do anymore because like the higher tier model just does that out of the box. And so I think it's just interesting, like to ask yourself, like, is it a good thing for you if like the base models get 1 or 2 order of magnitudes better, and you want to be positioned where it is a good thing for you?
I love that idea. I think it's a phenomenal framework, actually. Like that could have solved so many unused tools and research for the past couple of years, which is, are you happy if models improve in terms of performance, in terms of accuracy? So that's actually a very helpful framework. Let's dive into the discussion on AI. So maybe to kick things off, talking about natural language analytics, and particular a problem that we were working on at Stanford, which is Texas SQL. We were particularly using it for using our LLM tool, but maybe just broadly, like do you find that sort of current iterations on Texas SQL work? Is this what is your perspective on evolving role of human analysts? If it does work, how do human analysts fit into that perspective? And then is there a diminishing role for human intervention? Like presumably, as AI scales in terms of performance, there can be areas where there's going to be humans in the loop, but there's also going to be areas where we just don't do that anymore. Like, for example, financial models were calculated by hand, and sure, there is a human in the loop now, but the actual calculations are no longer done by hand. So, do you see? Let's pause there, and then we can kind of keep going on the discussion.
Just to key off your last thing, you mean like sort of, spreadsheets, like pre-spreadsheet software, there's like an actual piece of paper where you're like updating the calculations, and like, we don't do that anymore. Thank goodness. Yeah. So, yeah, I mean, I guess taking a huge step back, I would say like code generation is fantastic, and it's amazing how useful it is already. I think kind of relatively early on, like to me, that was one of the first applications where it was so much better than I expected it to be, several years ago when like, Codex or other models first started coming out, that was a really interesting thing to pay attention to. I mean, in the specific case of like SQL, the use case is like, I have some piece of analysis I want to do. Maybe it's very specific, like how many daily active users did I have last week or something like that. Maybe it's something very general, like, hey, I noticed that, our revenue is up. Why? Like, what specifically happened? And there's like probably 50 different components of that. And, some of those things are noise and some of them actually have some meaning into them. If you sort of take the range of like things that a human analyst was doing. So I guess what I would say is that like, the task of, given a set of existing tables that are like clean and well specified, and I can sort of give you the schema for them, and I have unambiguous columns, and I can just say, write me a SQL query that does X function. I think that problem is very well solved already, and will just kind of get like beaten down into the earth in terms of like how well solved it is. I think the problem, maybe there's sort of like two problems that I think are like harder to solve. One is that nobody's ever seen a data warehouse like that. Like, I don't know, anywhere I've ever looked, it's just like quite chaotic, right? There's like 30 different columns that are supposed to be MRR. One of them's right, but it's not right in July last year, so you have to remember to ignore it then. There's all of this kind of like domain knowledge. Similarly, there's like business specific, knowledge as well, right? It's like, how do we recognize revenue? And, how do we deal with, for example, different things that are kind of specific to that company? I think that's a harder problem to solve. It's potentially harder depending on who you're trying to solve the problem for. So if like the experience you're trying to give is like somebody not on the data team is just asking a question and they're going to get like an answer that they can just, take and start immediately using, that's like an incredibly high bar, right? That's like a kind of zero human intervention bar. A lower bar is, can you make the analyst more productive on their own, right? So it's like, you're not spending time doing rote stuff. You're spending time doing thinking that's kind of like, high value. And that, maybe just to make an analogy for people who are more familiar with code gen, I feel like one of the things that just kind of, general code gen is useful for is like not having to look things up that are kind of like well-known how to solve. It's like, in the past, I would read 5 Stack Overflow posts, sort of synthesize them in my head, and then, write the code. Now I could just say, please give me something that does this, and don't make me install image magic, and then like the model does the synthesis for me. So anyway, that's kind of like a broad answer to your question in terms of what I think it would look like. I mean, for human analysts, I think the answer is it's going to change the way that people work and like the sorts of things they focus on, which I think is broadly useful. Like that's broadly good for human analysts. And so like, the Hex guys, for example, have this interesting blog post on Jevons paradox. This is observation from the Industrial Revolution that, as the cost, as basically like as it became easier to produce more coal, you might think that people would, or as steam engines became more efficient, you might think people would use less coal, but actually in aggregate we used more because it just unlocked more use cases, right? So it's like before, the very, very beginning, the only thing that people were using steam engines for was like pumping water out of coal mines, right? Because you got the coal right there. It's sort of like the first thing you could do. But as they got smaller and more efficient and more miniaturized, you could suddenly do things like put them on trains. And that like increased aggregate demand, even if every individual engine was more efficient. And so, anyway, in a similar way, if you just imagine that like each analyst is like 10 times more productive, does that reduce the total amount of analytics that's done? Like probably not. It just means that we'll look at many, many more things.
And maybe another way to put this is it becomes more efficient. So then on a unit economic basis, because of that efficiency, it enables more people to participate, increasing demand, increasing the number. I guess you could say the number of people who are utilizing this technology, and similar to the train analogy there.
Yeah, maybe the one other thing I think about for this is like, what's the evaluation loop? Like, I think one thing that's interesting about code generation. So if you're a software developer and you get like some block that got generated, you can look at that and like decide if it's right or not. And even if you're not sure, you could run it, right? Like you have this natural eval. It's just being a software developer who like understands what the code does. If you think about that analogy in like SQL land, sort of analytics land, if you're selling to the data team, you have that, right? But someone can look at the query and say, yeah, this is right. And I know that this column is trustworthy and this one's not. If you think about trying to sell the tool to like a non-technical user, then you have to solve that problem, right? Because like they don't necessarily know that, don't use this MRR column in July, don't use this table, use that table. This query isn't actually doing what you think it is, and it'll run. So you don't necessarily even get that kind of like compile time or runtime feedback, if you will, that like the thing just didn't run. Like the query might run and give you a result. So I think if you're selling to the audience, you think that sort of less technical audience, you think a lot more about like how do you embed that eval loop for the user so that they can tell whether the generation was successful. And I just think that's like to our earlier conversation about problems looking similar from afar but really different up front. That means if you're like selling this product to like a data team, that's a really different prospect than selling it to a broader company, and you're going to kind of you're sort of going to let them self-serve, if that makes sense.
And how do you foresee this changing how companies operate, how they're structured, and how decision making is made? So, for example, let's say someone is thinking about, do our customers, should we develop this product for our customers, and they want to, and maybe in the past they'd have a data analyst run some analyses, and then that analysis would be handed up to a maybe a CPO or a chief product officer, and then they kind of think about the analysis from there. Whereas now you could think of the analyses coming straight from maybe a chief product officer, maybe straight from an executive who can run the analyses themselves. And maybe, I forgot who, I think may have been Rockefeller who basically said that one of your chief goals is to get people who work for you to tell the truth, because most of the time people are going to lie to you in order to, in order to make things seem like they're positive, they're optimistic, they're going well. And your job as a leader is to get the truth out of them. Curious to hear your thoughts.
Yeah. Well, one thing I think about is that producing data that can be used by the machines will become more valuable, as opposed to like, are you prepping things for machine use, or are you prepping them for human use? So like, is one, again, like hopefully familiar to your audience example of that. It's like, at least for me, when I was writing code before, I would typically write comments at the end, if at all, right? Like I would write the modules to do whatever I wanted to do, and then maybe I would go back later and document it. Things like Copilot kind of switch that, where there's actually like a big incentive now to like write comments before you actually define your function block, right? Because you'll get better generations if you do that. And so that's kind of just like a small way in which like your behavior is shifted a little bit. And if you shift that, that's better for the model, right? Like you're going to get better results out of the model. And so, similarly, like one thing that I've wondered about in data land is like, what does it mean to like produce data assets in a way that's going to be really good for SQL generation, right? Like you probably want to have like a handful of like really, really high quality data assets. So like these tables are like very trustable and they're very well documented. And maybe I even have like a corpus of historical SQL queries. And maybe I care more about finding out like for each different dashboard of the company, like this is the query that's actually computing what MRR or active users or whatever is there. Like it sort of incentivizes you to prepare things in a way that you can push them into a language model in a way that wasn't true in the past. And so that's probably like one shift that I would imagine for teams. I don't even think it's something that foreign. It's like something that I think we already kind of saw with like the rise of DBT and other data modeling tools, where it's like, part of the job of the analytics engineer became, how do we produce really high quality granular, data sets? So we have some transaction stream that's getting dumped in from Stripe or something like that. And that's kind of like a raw, there be dragons, like you have to do some work on that, but you want to resolve that into what is the right definition of a transaction. And here is that table at that granular level. But, I've sort of applied the business logic to what those things mean. And there was more value to having that once sort of data modeling became easier, because once you have that granular table, you can produce all the downstream things and trust them, right? And so I sort of similarly think that like data prep for the models will end up mattering more than it has in the past. That's one thing I'm thinking about.
And it's interesting because there's kind of two schools of thought or two trade-offs, which is if you if you move fast and break things, and you build your MVP. Many times people say your MVP doesn't need to be the technology that you continue to use throughout the company's life cycle. On the other hand, you can also think about the fact that if you made an incorrect or sort of mistakes in the design process earlier on, those issues can compound later down the road for you, resulting in sort of poor data quality. And sometimes you do want to make sure you get it right at the beginning. And it seems as though like this is one of those areas where it'd be an argument for the second camp where yeah, I totally agree. One of the key issues we ran into for Texas SQL is just the quality of the underlying data, and the structure of it does make sense, and is it easily understandable to someone who's not technical. And so I think like that's, unless you have two alternatives. Either you start out with a high quality data structure and rationale for how you source the data, or two, you're able to kind of clean that data later on, which is also a feat unto itself.
Yeah. Well, this may be like an unpopular view, and I feel like I'd be creating pain for my past self for saying this, but like I actually think it's rational for most companies not to prioritize data quality really early on, because I mean that's not the thing that's going to make or kill the business like at the seed stage for like almost every company. And it's so anyway, I feel like heads of data are often in this position, and when the first data person who gets hired in, it's just like they're looking at this like crazy set of things, and nobody's ever looked at these tables before, and it's a total disaster, and all this wailing and gnashing of teeth. But if I think about like the very finite resources that like a seed stage company has, and is prioritizing like data quality the right thing to do early on? If that's your core business, sure. If it's not, and for many companies it's not, then I think it makes sense to think about it later. It's sort of one of those nice problems to have, where if you get to being like a Series C company that actually is for the first time like investing in its data engineering and data science teams, it's going to be a mess, but you kind of have already succeeded to some extent to kind of get to the point where you have that mess.
Right. Yeah, I definitely see what you're saying. The make or break issue is whether you have your product is something that people want. You found your target customer persona. All of the things can be solved down the line.
Yeah, tech debt is rational, maybe is another way of putting it. It's like you should be incurring tech debt.
That's a great way to put it, yeah. And so kind of continuing the conversation, in so recent years, we've had an intense focus around the modern data stack. A lot of the hyped up or sort of popular IPOs the past couple of years have been the Snowflakes, the Confluence, the HashiCorps, if you kind of put that into the data stack realm. Maybe that's more just pure intro, but anyways, how do you perceive the current state of this trend? Like, is the initial hype diminishing? I remember, seeing just from one way to look at this, it's not the most important way, but like, you look at EV to revenue multiples during, kind of post-COVID era, we're reaching 40 times, 30 times, and now they've kind of crashed to, high single digits. That's one way to cut it. But how do you foresee that kind of the next phase and the evolution of the modern data stack? Is this transitioning landscape? And like, what implications do you see for startups? So forget the EV to revenue multiples. Let's talk about product. Like, will we witness a wave of consolidations, of different kind of change in the industry?
Yeah. Well, I guess I always think about it in terms of like what problems have been solved and what problems sort of remain unsolved. And so, maybe I'd make a distinction between like the analytics side of the data infrastructure stack and maybe call it like the more procedural side. So like the analytics side, I would put things like you're ingesting data into your warehouse, you're doing transformation on it there, you're preparing it for use in different places, all of your business intelligence, like that's one side. And then, the other side would include things like training models, feature engineering, even like procedural data pipelines, like things that are more like, Python or some other procedural language scripts as opposed to SQL queries. And so, I mean, on the analytics side of the world, I feel like there was a lot of progress made over the last like 5 to 10 years. And what that basic stack looks like today is so much better than it was 10 years ago, right? Like we have a set of components that work really well. Like you're using something like a Fivetran or other data ingestion tool to put data into your warehouse. We have these like scalable, sort of largely manageable without that much work, cloud data warehouses. We have good tools for doing transformation inside of the warehouse. And we have good ways of getting data out, right? So we can sort of like take things and put it into these different SaaS tools or embed it into an application. And then similarly, I think some other things that end up in that category are like data quality monitoring, data cataloging, where like we know what those components look like. And so, part of it to me is like we actually, there's a lot of success in making the analytics side of the stack better over the last 5 to 10 years. And I think we've kind of reached a point where we're ready to, I don't know, spend some time like using that stuff. We're sort of like in the deployment phase, so to speak. And it's nice that a lot of the problems have been solved. It's not like all the work is done. We've gotten to like a much better state. Meanwhile, I would say like on the procedural side, I think that things have not gotten the improvement has been much less there than it has been on the analytics side. So like even, procedural data pipelining, for example, how do I quickly like spin up Python runtimes that I want to use to like execute jobs? Things like just sort of like remote function execution that you need. So if you sort of think about like your life, if you were doing I'm ingesting data from Stripe or some other tool. I want to run some analysis in those transactions. It's going to power some dashboard. We have pretty good tools for all of that stuff. If you think about doing something different, where suddenly you're using like a Dagster Airflow prefect to run a bunch of scripts, and I'm using that for some feature engineering use case, or even just like some set of data jobs that can't be easily expressed in SQL queries. Like that stuff, I think is sort of just coming into the phase where it's getting a lot better now. And one reason why I think it is getting better now is that the AI infrastructure needs have kind of like accelerated development in some areas to the benefit of all these adjacent tools as well, if that makes sense. So like if you take like model inference, for instance, where I have some PyTorch model that I want to run in production, and I care a lot about scale up and scale down on day one because GPUs are expensive and scarce, and I care a lot about like cold start times on day one because there's a big difference between something that I can have running in a few seconds versus minutes. There's like spillover effects from that infrastructure getting better that I think will be useful sort of like more broadly in the data category. So like durable execution getting better is good for data teams broadly. Just having like very simple remote function execution, like serverless type function execution, where I don't have to think about where or how the script runs. I can just run it. Like that getting better is to the boon of a lot of different data applications. And so I don't know, that's the side of the stack that I think is interesting right now, where I feel like I'm spending time.
And I think another contributing factor here is, at least in the data sort of data stack community, there is a tremendous focus on open source that we didn't really get to see as much, I think, as we did in we didn't get to see as much in application software and maybe cybersecurity, where so much of the modern data tools have open source software, which one, if you are a developing engineer, you're able to you're able to learn what high quality code looks like from engineers from all across different companies. And then two, so it kind of sets standards across companies, and two, it also rapidly improves the learning rate of everyone else. So that's one of the things I was a little bit worried about that was happening to the AI world, is that if training large models essentially becomes kind of like creating a fab manufacturing facility where it's so expensive that you don't really want to release that open source. Like, what does that not just do to the economics of the industry, but what does that do to the learnings and the further development of the entire ecosystem, right? Because 2010, 2020, we had all these open source models that people could tweak and play with. And, obviously everyone knows like the transformer started at Google, that initial innovation was taken across different spaces, not just to text, but also to vision. And that kind of dissemination of knowledge is really important to the space.
Yeah. So, I guess a couple of thoughts on that. It's like one, I sometimes joke that, in the data space, like what is the value of open source? Maybe like two things end up being a lot of it. One is you don't have to talk to a salesperson to use the tool, right? So it's like, if I want to try the thing out, I'm not like gated. I can just like actually like pull it down and run it and try it and see if it's something that I like. And, the second is, very slight modification. It's like, look, there's this data ingestion tool. It does everything I want to do. It just does one thing that I don't. Am I begging the company to like make a change for me and like try to get onto their roadmap, or am I just making that like 5-line edit myself in the open source? Like, that from like an adoption perspective, those are a couple things. But I mean, I agree with your broader point that just like, having things be open is important for lots of people seeing it and getting new ideas and going out and building new unexpected things. I'm kind of, I think like open or closed, it's hard to keep technical secrets, for very long periods of time. It's always a question more of like how long as opposed to if, and so, I mean, again, just to make like another historical analogy, like for chemical engineering, something I think is interesting is like you do all of this R&D to come up with a better process for making, aluminum or whatever. But at the end, it's sort of, there's like a chemical formula that expresses that process, right? It's like it's been condensed down to this like really small artifact. And it's very hard to keep things like that a secret for long. And so, the history is usually like someone develops it and they have a monopoly for a few years. But, if you kind of like want to continue being at the forefront, or I don't know, whatever, being the number one like aluminum company or whatever, you have to like continually develop new things, because like the half-life of how long anything stays a secret is not that long.
Do you have, going off a little bit of a tangent here, do you have any piece of advice for companies you work with on whether they should open source pieces of their software or not? Because oftentimes that we saw in the past decade is larger players like AWS and Google could take your open source software, dedicate a couple dozen engineers to it, and say, hey, we've got the open source software and we will do upgrades to it. And so you don't have to, there's less of an argument for having, the argument you typically is, we'll support it, we'll update it, we'll keep developing on top of the features.
Yeah, maybe you're like alluding to like the Elasticsearch, OpenSearch, like So I mean, I think the answer is just what is the purpose of open sourcing the tool? And a lot of the times it does come to one of those things that I mentioned originally. Like, is it really important that people can try this in a low risk way, right? So it's like they come to the site, they learn what the project is about, and you want to make it very easy for a developer or whatever technical role you're targeting to try your project and see its merits, like they can directly experience it. That's one reason why open source is useful. The other, again, is like we were saying, is does that customization matter? Is it like important, that people be able to customize it for their own needs? And sometimes it happens like on a specific per customer basis. And the other times it happens when, you want people to use your technology and build things on top of it that sort of specializes it to their use case, right? And so, we see that a fair bit as well. But I mean, I think the answer, to your question is sort of like, what is the purpose of open sourcing? Is there sort of a compelling reason why this product is more compelling with an open source component than without?
Yeah, that's a brilliant way to put it. I think, and it doesn't need to just be through open source, right? One of the key innovators of the bottoms up approach was like Twilio. Ask your developer about it. And so
right.
Maybe for AI, for many AI engineers today or AI leaders of startups thinking about, is there ways to reduce friction that are not just open sourcing my software? Maybe you can open up an API to your core offering.
Totally. Yeah, that's a great point.
So thinking about AI agents, what are the critical elements required to operationalize AI agents? Like, how do you assess the timeline for this evolution? We've been told that this is really the next evolution. Kind of the analogy here is if language models are like computers, AI agents are like hooking up the computer to the internet. Are we looking to add a breakthrough in the coming months? Like, what, if you have to break down of what is required for AI agents to be integrated into actual sectors, of what needs to occur?
Yeah, I think maybe the high level answer to that is I think what has to occur is that they're kind of reliable and predictable at like the level that like a human might. And there's a bunch of things that go into that. And by the way, like having like the human affordances is kind of a historical thing too. Like maybe in the long run, it's not important that like the behavior is somewhat comparable to humans, but like in the short run, I think it is for adoption. So what I mean by that, for example, is like, hopefully, if you ask a technical person on the team to do something and they don't know how to do it, they'll tell you, or like they make an attempt to do it and it doesn't work. Like you can find that out in conversation, as opposed to, hey, here's this thing I tried and who knows, but I'm just going to keep like plowing ahead. And so I mean, I think a lot of like the challenges with agents today are like, their brittleness, their unpredictability, like some opacity into what they're actually doing. I mean, maybe one of the questions now is like, how far away are we from solving those problems, and like, what will it take? Sort of, can we take like a language model in a for loop and kind of just like add more logic to it to get to that level, or is it going to like take some more fundamental research? Like, I generally think that like it probably is more on the we need some new basic research side. Like, you probably need something that looks more like goal-seeking behavior embedded into to the agents. They can kind of determine whether they're getting closer to their goal versus not. I think like RLHF has come to like mean like, humans giving feedback on like specific outputs. But like, I think if you sort of like take it more broadly to mean like, is this agent getting closer to accomplishing the task that I wanted it to? Like, maybe you need something that looks more like that. So again, maybe just to make it super grounded, like if you take some specific example, like, I'm traveling to the city on this date, like, can you book a flight for me? And you sort of see all the ways that like AI agents go off the rails and like trying to do those things today. You could sort of like start thinking about like, how would I get to ground truth on, or some good proxy for ground truth on whether we're getting closer to that goal. Something doesn't work, like this OTA isn't working right now, so I'm going to switch to this other one. How do you kind of have like enough goal-seeking behavior that it's not just, hey, I sent these requests to this API, I got this request back, I'm going to like throw that in the context window and make one new generation. I think it'll end up being more sophisticated than that.
Yeah, and I think
people are working on that. So like, I'm optimistic that people will make those breakthroughs. Like, people are obviously working on, there's lots of different takes on agents from like a research perspective, but I do think it's probably more something that's going to require novel research as opposed to retrofitting what we have now.
Right. And I think that's kind of goes to the debate of, do you put guardrails on what exists now, or do you change what you've developed and innovate on that fundamental innovation? It's sort of like, do you adapt the tool, or do you change the tool? I mean, along those lines of kind of basic research, is there any areas that you're interested in right now? So for me, our paper was just presented in NeurIPS, and for the biggest topic, at least in LMs at NeurIPS, was LMs as operating systems. You piecing together a retrieval model to be almost like moving information into memory for computers. All these other types of metaphors you could kind of take this to. But any other areas that you're interested in?
Yeah, so I think that's interesting. Maybe something else I've been thinking about, I alluded to earlier, is like diffusion models for different modalities, I think are interesting. And so, I mean, there's a few reasons for that. Like one, the unit economics are different than they are for language models. Like, I think, the estimated cost of like training Llama 2 was like $20 million or something, versus Mosaic had this set of posts on like training a stable diffusion model for like about 150K.
Yeah.
And obviously that's also true for inference. By the way, speaking of Jevons paradox, there's like an interesting thing there, which is like, okay, given that's true, we should consume more of it. And so, you start seeing people do more expensive, like video diffusion, for example. If we can produce images relatively cheaply with diffusion, well, why don't we just scale that up and like start using those expensive cycles to like do video diffusion, for example, or like we should have higher resolution or whatever. So anyway, it might be the case that we end up getting expensive in that territory too. But I mean, the other thing for me is I just found like the theoretical development of diffusion models over the last like few years really interesting, like the consistency models stuff. Even like the probability flow thing where you can like replace the SDEs with this ODE. Like, just the research is really fascinating on its own. And maybe on the more practical side, because costs have come down and because throughput has gone up, like I think we'll see more real-time diffusion applications very soon. There's this cool project where somebody was getting like 70 plus images a second through Stable Diffusion Turbo, just on like a commodity, like consumer GPU. I think it was like a 4090 or something. And so, if you just sort of think about like having those tools available and kind of, putting them in lots and lots of people's hands, where it's just easier for people to toy around with, play with, do full checkpoint fine tuning, sort of experiment with diffusion models, it's somehow like more accessible than a lot of the language model stuff at like a more fundamental level, if that makes sense. And so that's one reason why I think it's sort of interesting and almost like a separate category.
And it also seems that the way the research world seems to almost work is there is an innovation in one area. So let's say computer vision, like AlexNet comes out, all PhDs, all the researchers focus on that one area. That leads to another innovation, maybe in text, and then everyone piles on that into text, and then maybe that informs an innovation, in vision again. It seems that I know some things you mentioned are more visual, less text based, or you just name some visual
or other modalities, like it's images, video, audio.
Right.
There's lots of things you could do with it. Yeah.
People are the point is people are ignoring a lot of the other modalities right now that maybe there's some key areas to go into, particularly for startups or researchers, and it'll be a fruitful endeavor. So kind of talking about AI, so research, and maybe talk about the infrastructure that can support that. You have classic ML inference for model. Classic ML infrastructure for model inferencing, and then how do you kind of grapple the newest innovations and infrastructure that's required to maybe support some of the things that have come out more recently, or maybe become more popular more recently, like vector embeddings and doing for data management, and how do you perceive the last mover advantage in the context of OLAP versus OLTP systems?
I see. And you mean for like model inference specifically, or kind of like for all these different subcategories?
All the subcategories as well, actually.
Yeah, I mean, I think so. One interesting thing is like when these problems come up in kind of like the life cycle of the business. So like if I think about like classic ML inference, for example, you're going from some model that backtests well to the first time that I want to put it into production. That transition was not as complicated from an infrastructure perspective in kind of like a classic ML case as it is for model inference. And partially it's just because like what would you have done in the past? Like one very simple thing you could do is like get some beefy EC2 instance and just rent it out 100% of the time and stick your model on it and just go. Much harder to do with like a consumer AI application today, right? Again, like GPUs are expensive and they're also just scarce. Like literally just having them there's always these trade-offs. Like, am I using this for training right now or using it for inference? And so these problems that like came up for classic ML infra, but like much later, happen much sooner now. So like on day one, you care about the scale up and the scale down back to zero. And, again, you care about cold start times like really early on. And so I do think it's interesting. These problems have to get solved like sooner in companies' histories than they would have otherwise. And so, one thing that means is like engineering teams are smaller, like earlier on, and you have like fewer specialists. And so people are probably more willing to outsource things like that early on.
That's a brilliant take. Yeah.
Yeah, and then I mean, for some of the other things, like I do think it's interesting to like think about like different like intermediate steps, like in like the evolution of different technologies. So there's this classic thing where like the first version of what people try to do feels like a retrofit or feels like a sort of transitional version of technology. So like the classic example is like fax machines or something like that. It's like, I've got two offices, I've got paper over here, you've got paper over there. What if we sent paper back and forth to each other, like with a fax machine? That was like what people thought about when you had sort of networking capability originally. And then there's this extra turn of saying like, well, what's like the native version of sharing things with each other using this technology? And obviously it's like just having the screen, right? Why do we need to print this out, sort of send it across to the other office to have the other person look at it on their screen again? And so, yeah, I do think it's interesting to think about for other categories, like, you mentioned kind of like vector embedding, vector storage, vector retrieval. There's lots of different takes on that right now. One is, I'm trying to think of what would be most interesting to talk about. Like, well, maybe just like one change is like, how often are you doing the embeddings? Is it sort of like I have some corpus of information and I embed once and I'm carrying that stuff around with me all the time, and maybe I embed it a couple of times, like I semantically chunk one way for this use case and I semantically chunk another way for the other one, but it has this feeling of like being semi-permanent versus no, I'm going to be generating embeddings on the fly all the time for different use cases, like dozens of times a day or something like that. And those lead to like really different infrastructure requirements, right? And so depending on which of those patterns you think is like the main way that people are doing this, like 10 years from now, like you need totally different, sort of pieces of infra. And I guess one thing I think about, like what are classical or like, analogies to that's happened in the past. And so, one thing I sometimes talk about is like pre-cloud data warehouse, like sort of I have a data warehouse that can run fast columnar queries. people just kind of use transactional databases for
Yes.
analytics, right? And there were all of these like tools that existed to like cope with the problem that wasn't a very good like foundational technology for this tool, right? So it's like you saw a lot of like, I guess we would call now like change data capture type stuff of like, you never want to query like the full table because it's like way too big. So you need lots of like derived tables down the line, and you want to keep them up to date. So you're kind of like percolating results from, new data comes in and you want to percolate it out to all of these other tables. But then, once we just had like cheap, reliable cloud data warehouses, a lot of that stuff just got blown away, and you just don't think about it anymore because like there was a more foundational shift in the technology. And so anyway, this long-winded way of saying that like I think that getting that right for AI infrastructure is really important. Like you care much more about like what the final state or kind of like long-term equilibrium way is that people solve a problem. Like what do I actually want to embed, and what do I want to do with those things, and what sort of capabilities do I need to enable? And you could choose that for almost any area of AI infra now, model inference, any of the things we talked about.
So two things. Your first point on making sure you stand up the correct ML infrastructure early on in the startup lifecycle. I experienced that actually firsthand, where I was at a machine learning role where I was my focus was creating a separate model architecture and endpoint for machine learning models, as opposed to before, where it was embedded into software development systems. And so that hadn't been an issue before, because many of the ML models, techniques were more traditional in nature and less using deep learning and some of the more recent innovations. And so as those innovations need to be incorporated, you slowly saw this need to bifurcate those two paradigms of the software team, software engineering team, and the more specialized machine learning team. And so it was curious to me that hadn't been done from the beginning, but it hadn't been necessary. And so I love that take. And the second take that you had on kind of my mind immediately went to the relational database as well. So meaning, in kind of 2010s, you had the rise of the local mobile, social mobile local, where you had all these consumer apps that needed more sort of NoSQL databases. Whereas we had visited the NoSQL database back in the 1980s and prior to that. But the paradigm had shifted towards the more kind of relational database. And then as you had these consumer apps come into the fray, we then started developing tools to support a new type of data infrastructure to support that. And maybe we're to your point, we're seeing that same development happening in AI now, where now that you have some of these consumer applications that require real-time inference, you're also seeing a new infrastructure develop. So some of these decisions and trade-offs that we had before, had decided to go down this path, we're going to kind of go down the alternative path we didn't choose because of the trade-offs that arise from this new application set.
Totally. Yeah. And maybe like one thing that's already happened is like another historical example is like, if you go watch like instructional videos or like resources on like relational databases like 20 years ago, specifically like for data use cases. So somebody wants to like, aggregate some statistics, or they're interested in, compiling sales numbers for a bunch of stores or something like that. What all that instruction is tuned to is the idea that people are going to run some queries to like extract the tables that they want. And then all of the actual number crunching is going to happen in like Fortran or something like that. That was like the pattern that people have in their heads. And obviously that's like not what happened, right? Like right now, so much of the actual analytics is shoved into the SQL queries, right? And like that to me is kind of the direction that like the cloud data warehouses went to. But it's very interesting that like what people thought we were going, if you sort of say, I have a bunch of relational data and I want to use it for analytics, how am I going to do that? When people were originally building the systems, they thought the answer was extract it from the database, run it through some procedural, pipeline, Fortran or whatever. That's not kind of what happened in the analytics stack, which is interesting, right? But it is sort of what happens in the procedural stack today as well. So anyway, it's interesting to me that the way we end up like using these technologies in sort of surprising ways.
Right. Agreed. And maybe for the last couple of questions, maybe we kind of just broaden this out to the tech world as a whole. What do you think about the interplay between innovation cycles and how that shapes power law distribution? So I think Bill Gurley mentioned, one way to view this is Bill Gurley mentioned that most of the returns are made in the latter half of a cycle, So maybe you have innovation that kicks off a cycle, and then you obviously have a crash, and most of the returns I think were received on the later half of the cycle. Like, what are your thoughts on kind of the power law distribution and how that impacts VC investing?
Yeah, so I mean, I think there's like a timing, if you will, like point there, and I sort of viewed like the kind of I don't know, interesting or contrarian thing that he was saying in that is that like maybe market timing matters more than people think. Like market timing is one of these things where in general, it's sort of thought of as something that like more serious investors like don't think about that as much. And I sort of viewed him as making kind of the playful take that like actually maybe this does matter like more than people think. There's a big difference between exiting positions in like 99 versus 2002 or something like that. I have less, I think, like opinion on that. I think that it's a very interesting idea. I just have less an opinion on it. I mean, in terms of cycles more broadly, I always think it's interesting to like distinguish between market cycles where there was like some fundamental technology improvement that like that sort of like pulled forward a lot of like interest, enthusiasm, et cetera. But like the thing fundamentally worked versus, kind of like pure manias, so to speak. And so there's historical examples of both. Like there's like this funny example from like the Kuwait Stock Exchange in like the 80s where there's like all these paper companies and none of them have any actual assets. And, it got, people are betting with each other and it got up to being like, tens of billions of dollars of sort of like paper equity, but there was not like a fundamental thing there. It's not like these, companies had mineral rights or they were actually doing something. Meanwhile, you could also look at like, what's a good historical example? Like the railroad boom in Britain or like canals, either in the US or the UK, where like, there was some huge fundamental improvement, right? Like the cost of transporting a ton mile went way down. It was just that people got so enthusiastic about it that it was sort of overinvested at some point in time. Although, not as many people know this, but like the early investors, there's sort of two rail booms that happened in quick sequence in the UK. And investors from the early one actually did like quite well. It was sort of only the second one that it got like very, very overbuilt. But, in the long run, again, this is kind of the Carlota Perez point. It's like in the long run, laying all of that rail was really important later. So we're really just like pulling forward demand from the future because it actually is very useful to have lower costs per ton mile between all of these factories and kind of like the later stages of industrialization, if that makes sense. So anyway, I always think it's interesting to like distinguish between those two things. And then, yeah, I mean, I think the other thing you mentioned was sort of like the power law distribution. Like, why is venture power law distributed? Is that right?
Yeah, I mean, just what is your take on? Why do VC returns? You can dive into why VCs follow the power law. Yeah.
Yeah, I mean, well, I guess one thing I'd say is like a lot more things are power law distributed than you might expect. Like there's, it's interesting. So like, what are there? So in economics, it's like things like book sales or like this, or like, I'm sure if you looked at like box office receipts, it would be like this as well. Even in other things like earthquake, like strength is power law distributed. So, I think if people are interested in studying this, there's like all these other, things to look at and kind of ask, why does it work in that case? Or forest fires is another example. Like the size of forest fires is kind of power law distributed. And so, I mean, if you think about it, there's probably like a handful of different effects, going on. One is this, sort of like Matthew effect type thing. Sometimes people call this like compounding advantages, where or like a pull you earn model, where succeeding a bit makes it more likely that you'll continue to succeed. So, you get the ball rolling, you win a few marquee customers. That makes it easier for you to use those reference customers to go win the next person. Suddenly you feel like you're sort of like the well-known solution for whatever problem that you're solving. That makes it easier to win the next person. That makes it easier to recruit talent to the company because it seems like you're sort of winning the category. So there are all these like self-reinforcing effects. That's probably part of it. There's also this like, I don't know, so-called like superstar effect where a lot of the demand is aggregated at like the best solution for some problem. So like one way of putting this is that, if you think that there's a lot of demand for food delivery, there's a lot of demand for the best food delivery application, but there's way less demand for the 10th best, even if the absolute difference in, product between the number 1 and number 10 isn't that big. Why would you use the 10th best one when you could use the first best one, right? So there's these kind of like demand aggregation effects. And then maybe the one, I don't know, people talk about this less, but I think it's interesting is that like a lot of times there's this effect of like things just not working at all, in the majority of cases, will produce these like power law outcomes. And so, one of the ones I like thinking about is, have you heard of like the Putnam exam for undergraduate, like for math students that take this difficult exam? Like the distribution of scores for that exam looks power law distributed as well. And like the reason is because most people taking it don't answer any questions. Like sort of the median score every year is 0 on the exam. And so, you could sort of view that as saying that like in the majority of cases, what's happening is that, people sort of, the exam is so difficult that you're sort of not able to get anything off the ground, so to speak. And sort of that's one reason why you'll sort of see these effects where it's sort of distorted by the fact that like the majority of things just don't work at all.
Yeah, it's very, very interesting. I mean, and I think most people when they discuss the power law, that they kind of take one angle in particular. But I love that the fact that you kind of cut it up into a couple of different slices there as to why it makes sense. And I think obviously you just kind of sort of allude to it, but obviously there's brand effects, and there's some of the more obvious reasons why kind of VC operates in a power law distribution. In balancing the rapid technological advancement that we have from effective accelerationism with the cautious, collective decision-making approach of effective altruism, like how can we reconcile the need for innovation with ethical and societal responsibilities? So we see a lot of discussion in AI today as ethical AI. Is AI secure or privacy preserving? Like, what is your take on some of these two camps there?
Yeah, I mean, so this is kind of, I think, well, what's interesting to me about this debate is that everybody, I think many of the people on both sides of it consider themselves techno-optimists, right? So everybody is sort of believes in the idea that we can dramatically improve, human experience by developing technology. And really sort of like the scope of the debate is just how do we apply that specifically to AI? I guess what I would say is like, in general purpose technologies have been very good for humanity historically. It's hard to go back in time and find something where, we would say, oh, we would have been better off without, without steam engines, or we would have been better off without rail or something like that. Like in general, these general purpose technologies are like quite beneficial. And so that kind of pushes me towards the side of thinking that that's probably the case in general. I think the other thing I always think is interesting is like, there's this kind of inherent way in which like anything that's really useful also has to be somewhat dangerous, because like, how could it be otherwise, right? Like if you're dramatically improved, like, maybe it's like a simple analogy. It's like, like power tools are more dangerous than like hand tools. But that's because you can partially because you can do more with them. So, so von Neumann had this paper that I like, I forget what it's called, something like, Can We Survive Technology? And he's writing it in like 1955, kind of like the height of nuclear Cold War tensions. And, he sort of considers this problem of like, obviously he's thinking about, sort of fusion and fission bombs and maybe nuclear power more broadly. And sort of has the perspective of like technology has become powerful enough that we actually do face some existential risk from it, but it's also incredibly useful, and you kind of like can't tease those two things apart. And so I think he has what's his sort of answer to this problem is that like there's no way around this problem except to grapple with it. Like unless you want to shut down the development of technology entirely, it's just going to be the case that over time you develop more and more powerful things. And you get extreme usefulness out of that. Like there's tremendous power to better humanity through that, but they also come with risk, just because again, like power and risk are just like so like closely intertwined. And so, I mean, to me, I think the upshot from this, and this is kind of what he recommends, is that like you shouldn't slow down. Like you need to continue developing the technology, but you should also spend time like thinking carefully about how to solve safety problems as they come up, which, to me is like what a lot of the large labs kind of do in practice, right? It's not, the arguments for slowing down are always, there's this question of like, what do you gain from doing that? And, at least the thing that he advocates is, at least how I interpret his this paper is just, if you want the usefulness, which we all do, you kind of have to grapple with the safety inevitably. There's kind of like not a free lunch.
In terms of how that feeds into, so maybe that would be a case for accelerationists, like given that group's role in I guess propelling AI? Like, would you say that is AI in a speculative bubble? Are we in a shift? So, does this feel like 2000 to you, where we had in late 1990s we had Google and Amazon. There was a bubble, and it burst, but obviously it birthed a lot of fundamental companies. Like, how do you view where we are in the cycle?
Yeah, no, I mean, look, I think this is sort of what I was trying to say earlier is like there was this like huge fundamental technological improvement, and like there will be a huge amount of utility from that. And so, I think that's great news, and that means that you want to be investing in those things because they actually matter. Like, how big is AI for kind of like all of human history, sort of or technological development? I think it's quite big. And so I think that's sort of the question that I find most interesting. Anytime where you see like a lot of investment into some area is fundamentally, is it really important that this thing succeeds? Will it actually meaningfully affect global GDP, like all human outcomes? And the answer is yes. That's always the question I feel like you think about for kind of market cycles is, how much of this is kind of sort of speculative driven versus fundamental tech breakthrough driven. There's always a bit of both, but the fundamental tech breakthroughs in AI are quite big, and we should be excited about that.
And for people building in this space, particularly a lot of founders in the space are technical founders. Like, do you have any advice for them on because we've talked about kind of more business VC, like maybe shifting for engineers. Like, do you have any advice for technical founders?
In general, I think solving problems that you understand really well and you feel like you have a firsthand perspective on knowing what a really good solution to that problem is a good guidepost in general. There's so many things, like so many if you think about like products that are just like a few degrees off from like really solving the problem, and that makes them just not that useful at all. Like they get almost all the way there, but they don't quite solve it. That's one reason why it's like so valuable, especially for technical people who are really close to the problems that they want to have solved and would kind of build something for their own past selves, so to speak. Like, I just think being really grounded in, does this really solve the problem, to the standard that like I myself would want it to as a customer? Like, is it something that I would have used it in my own past work? Sort of like one broad piece of advice for technical folks. Yeah, maybe I'll stop there.
Okay, got it. So final question, we maybe just a word of advice for AI founders, in terms of, if I compiled an ETF for you and you could sort of go along an ETF on companies building sort of GPT-4 wrappers, like, would you be long or short? Should people kind of get out of the way of OpenAI, or is there some base here to build upon?
Yeah, I think sometimes like the framing of the question, like I feel like there's this thing where like the way that this categories get described sort of like implies a view. So like GPT wrapper, so to speak, sometimes it sounds like something that's kind of derivative, which I think is maybe like not fair. My answer to this question would just be closer to what we were saying earlier, which is do improvements in the base model, like if the base model gets 100 times better, is that good for what you're building or not? Because you sort of bake in like the assumptions about performance improvements. And I think the answer is, in some categories, for some companies, the answer is clearly yes. Like, if you're very specialized to solving a specific problem for a customer that you know really well, and you're deeply embedded in their workflow, and if the model gets better, that's great for you. You could call those wrappers or not, if they're fundamentally just like using one of the foundation model companies to do that. But I think that actually solves a real problem, and those companies will benefit from continued improvements in the models. Contrast that with things where, if you think it's bad for you if the base models continue to get better, then I think you'd have to think pretty hard about whether you really want to do that. Maybe that's like the distinction.
Got it. Yeah, I think that's a great way to frame whether or not what you're building is actually used for and can withstand this test of time, or it's maybe time to get building something else. Great. Thank you so much, Slater, for joining us, and everyone.
Thanks for having me.
Yeah, that's our interview with Slater. Collective Nation, as we wrap up another episode of the podcast, I want to express my gratitude to our guests and to you, our curious and passionate listeners. Today's discussion has once again illuminated the terrain of AI, offering us a rare glimpse into the mind shaping the field. As always, we're building this podcast with the GenAICollective community, so please reach out with any feedback or suggestions. And if you'd like to be a guest on the Collective Intelligence podcast, please get in touch with us. Details for doing so will be in the show notes. And if you enjoyed the episode and like to support the podcast, please leave a review or comment on your favorite podcast platform. Thank you for being a part of this journey. Until next time, keep questioning, keep learning. Thanks.